Okay, before moving ahead, let's discuss about cards. So how many cards there are there in the pack of cards? Yes, 52. In those 52 cards, 26 are red cards and 26 are black. And in a pack of 52 cards, there are 4 shoots of different shapes. 13 red and heart in heart shape. And let me write heart also. And 13 of diamond shape. Thirteen spade shape, somewhat like this. Spade. There's a idiom calls a spade, right? If my memory is working well. This is called a club, also known as chidi in Hindi. Okay, so let's honor their color, all in red. We cannot write black on black, so let's leave it like this. So there are 4 shoots. These are known as shoots. Okay, and in every shoot, there is a there are cards from 1 to 13. 1 represents ace. There are number cards from 2 to 10. These are number cards. And there are face cards. 3 face cards are there. Starting with 11, 12, 13. Okay. 11th number card is known as Jack. It's a face card and also known as owner card. And then comes the Queen on 12th. Queen and the King. And these are known as face cards. And Ace, Jack, Queen, and King. These are 4 owner cards. We can call them owner cards. Why it's not working? Yes, let's leave it then. These 4 are known as owner cards in a shoot. So if there are 4 owner cards in a single shoot, so how many owner cards, total owner cards, are there in a complete pack of cards? And we are talking about a shoot. So 4 into 4, 16 owner cards will be there. Total number of owner cards in a pack of cards, there will be 16. And in a particular single shoot, there will be 4 owner cards: Ace, Jack, Queen, and King. So that's all what you need to know about cards. Okay. Any questions? No questions. Any doubts?
No, sir.
Okay. So let's now discuss some questions. This is a previous year question. One card is drawn. No, this is not a previous year question. I'm not sure. From a pack of 52 cards. What is the probability of it being either red or king? Or the card being a king. So what's the probability of the card being red or king? Okay. So let's name the event of being a red card as event 1. Card being red. The withdrawal card. Okay. E2, let's call the second event as the card being king. And what we have to find out is that either E1 or E2. So we can write E1 or E2 with union, as we have discussed that this represents OR, this represents OR, and intersection represents AND. Okay. So we need to find out this. So we know P of E1 union E2 is equals to the probability of E1 plus probability of E2 minus probability of E1 intersection E2. So now we need to find out the probability of event 1, which is the card being red. So how many total number of cards are there? So there are 52 cards. Total possible outcomes are 52. Number of favorable outcomes, favorable outcome here being a red card. How many red cards are there in 52 cards? Come on, tell.
26.
Oh, yes, 26. So this is the probability of event 1 where the card being red. We are discussing with the probability of withdrawing a red card. Plus probability of card being king. So total number of possible outcomes is the same. Okay. And the card should be red. The card should be king. So there was one king in a suit. There were total 4 suits. So there are total 4 kings minus. Now this is the condition E1 and E2 where the card is also red and the card is also king. So how many red kings are there? Red heart king. Yes, that's one case. And red diamond king. So there are 2 kings of red, right? So 2 by 52. Is that clear to everyone that how we have written and solved for the probability of the card being red and the king simultaneously?
Yes, sir.
So now the probability will take the LCM. 26 plus 4, 30 minus 2, that becomes 28. Yes, 26 plus 4, 30 minus 2 becomes 28. Okay. 4 7 ja 28, 4 13 ja 52. Okay. 7 by 13 is our answer. Clear?
Yes, sir.
Let's now discuss more examples. The probability that card drawn from a pack of cards will be a diamond or a king is what we have to find out. Okay. Simply even being the card being diamond, and E2 is the event where the withdrawn card is king. We have to find out the probability event even or event E2. Simple probability of even plus probability of E2 minus probability of both of the events happening simultaneously. Intersection, the common point. Okay. So probability of event 1, where the withdrawn card is diamond. Total possible outcomes 52. How many total diamond cards are there?
30.
Yes. Total possible outcomes 52. How many kings are there? 4.
4.
Right. How many king diamond are there?
1.
1. Simple. Easy peasy. 13, 14. 13, 4. 17 minus 1. 16. 4, 4 is 17. 4, 13 is 12. Sorry, 4, 13 is 52. 4 by 13 is our answer. Clear? So similarly, these kind of questions can be generated. Let's now solve some more questions. Next question is, we have to find out the withdrawn card being a queen of club or a king of heart. Okay, let's call this name as event 1. This is what we need to find out. Let's call this event of withdrawing a queen of club as event 1. This as event 2. So probability of even or E2, same formula. Both of the events happening simultaneously. Total possible outcomes withdrawing when we are withdrawing, here is a condition. When withdrawing a single card from the pack of cards. So how many queen of club are there? 1. How many king of heart? 1. How many queen of club that they are king of heart? No, that's contradiction. There cannot be a single card like that. So 0. That becomes 2 by 52. 1 by 26 is the answer. When 2 cancels 52, it becomes 26. That's our answer. Is there any doubt?
No, sir.
Now comes a fantastic questions. Okay. The question is, we have to find out, there are 2 cards withdrawn this time. Two cards to withdrawn anyway. And we have to find out the probability of both the cards being aces. What is the probability of withdrawing both cards aces? Okay. So this time, what is the probability of an event? Number of ways of getting the favorable outcome, favorable event or outcome upon number of total ways of event. So how many total number of ways are there to withdraw any 2 cards? So how many cards do we have? 52. And we have to select when we are withdrawing. So we are just selecting 2 cards in any way. So how many total number of ways are there to select 2 cards? We are selecting 2 cards. We have studied a formula for this, selecting R elements from N, right? So we are selecting N is 52. We are selecting two out items. R is 2 here. So total number of ways for selecting two items from 52 are 52 C2. That is the total number of ways for selecting two cards out of 52. Now, number of ways for favorable event. What is the favorable event? These are the total cards. The favorable event is being ace. So how many aces are there? Okay, if we calculate, with every shoot there is a ace and there are total 4 shoots. So there are 4 aces. How many in favorable chances when we have to select both of the cards as aces? So we have to select 2 aces from 4 aces. And in how many number of ways that we can do so, because favorable event is being selecting 2 aces, and we will be able to select 2 aces only if there are all aces we are selecting from, right? So the number of way to select 2 aces from 4 aces will be written here. Are you able to understand why only 4 aces is that we have considered this time? Because we are counting for the favorable number of ways for favorable event. Earlier we were discussing about total. So there were total 52 cards, but favorable was only 4. That's why we have considered 4 this time. Are you able to understand that how have I written the number of ways of favorable event and number of total ways of event? Is that clear? If there is any doubt, you can ask. See, let's understand it here. The formula of probability of any event is number of case. Let's write it like this: number of cases favorable to the event that we were discussing, to the event E here. Favorable cases only that we want as per the event, divided by total number of cases that are there. In this question, we were discussing about the event was selecting. Let me write different way in the question way. Withdrawing 2 aces. That was our event basically. So event was that we are withdrawing 2 cards, and favorable event is to withdraw 2 aces. That is the favorable event. And what's definitely that is going to happen? We are to withdraw 2 cards from the pack of 52 cards, and the favorable event for us being when we withdraw 2 aces. So the total number of cases will be, we will withdraw 2 cards from a pack of 52 cards. That is the total number of cases. But the favorable event being that we will withdraw 2 aces only. Okay, so if we withdraw 2 aces, how many total number of aces are there? 4 aces. Now, the number of cases favorable to event. So how many ways are there to select 2 aces out of 4? That we have a formula to select R things from N, that is NCR. So similarly, number of ways for selecting 2 aces from 4 aces, 2 cards from 4 favorable type of cards is 4C2. This is the number of cases favorable to event E divided by now total number of cases, total number of ways in which we can withdraw 2 cards. So there are 52 total cards. We can withdraw 52, sorry, 52 C2. We can withdraw 2 cards from 62. Basically, we have to withdraw. We have to select 2 cards from 52 total cards. In how many ways? In 52 C2 ways. Because we have studied about the formula that NCR is the number of ways of selecting, choosing, picking R things out of N. That is what NCR is. That is what NCR is. That's what we have studied. So that's why we will say that the total number of cases to withdraw 2 cards is 52 C2. That is total number of cases, out of which the favorable case being withdrawing 2 aces. That number of cases will be given by selecting 2 aces from 4. So 4C2. Is that clear now that why we are writing it so, probability of the event? Any doubt? If there is any, I'll explain again. Is there any?
Sorry.
No? Sorry, can't hear you properly.
No, sir.
So 4C2 is 4 factorial. NCR is basically n factorial divided by n minus r factorial into r factorial. So 4 factorial, 4 minus 2 factorial into 2 factorial divided by 52 factorial and 2 factorial into 52 minus 2, that is 50 factorial. That cancels 52 to 51. And this also cancels this. 4 factorial is 24. So 24 by 2 becomes 12. 12 by 2 becomes 6. And 6 cancels. And 6 by 2 becomes 3. 52 by becomes 26. 26 by 2 becomes 13. Okay, so there is left 3 by 13 into 51. Now there is also one more. 51 is 17 into 3, right? So 3, this cancels this. Now this becomes 1 by 13 into 17. Now who can calculate 13 into 17 so fastly? 7, 3, 10, 2, 1 carry. That becomes 1 and 1 by 2, 2, 1. क्या हो गया ये? I think laptop is getting hanged. Wait a minute. I don't know. Let's leave this slide like this one. Our answer is 1/221 is the answer. 1/221. That was a really good question. Now let's move to some different kind of questions. Anyways, what is this here? Next question is tickets numbered from 1 to 20 are mixed up together and then ticket and then a ticket is withdrawn from random at random from random. What is the probability that the withdrawn number withdrawn number, okay, the drawn number is a multiple of 3 or 4? Let's name the probability of being the multiple of 3 as event 1, being the multiple of 4 is as event 2. So how many total choices do we have? There are 1 to 20 numbers from 1 to 20. Okay. Now for the event 1, how many favorable cases are there? For the event 1 being the multiple of 3 means 3, 6, 9, 12, 15, 18. Now 21 will not be included because there are only numbers from 1 to 20. E2 event being the multiple of 4. So 4, 8, 12, 16 and 20. 20 is included. Now simple, it's ticket ऐसे ही है ना? It is just that we have to withdraw a number basically. So probability of event 1 or event 2 or is union probability of E1 plus probability of E2 minus probability of E1 intersection E2. So how many favorable cases are there for event 1? 1, 2, 3, 4, 5, 6. 6 by how many total? 20 numbers are there. 20 tickets are there plus 20 total tickets. How many favorable? 1, 2, 3, 4, 5. Now, how many common are there? Like intersection is basically the intersection means common elements of both of the events, common sample points. So 4 is common? No. 8 is common? No. 12 is common? Yes. 12 is also a multiple of 3 and also 4. Is there anything common else? No, nothing else. So only 1 upon 20 cases. Only 12 is that particular number. 12 is that particular number ticket, which is also a multiple of 3 and 4. Intersection means and only, na? Okay. Is this thing clear about
Yes, sir.
intersection? Taking 20 as LCM, 6, 5, 11 minus 1, 10 by 20, half, 50% chances. 0.5 is the probability. Clear? Slowly we'll increase the level of questions. Now, is this question clear? Is there any doubt? Are there any questions? Let's move ahead then. The next good question says a bag contains 8 red and 5 white balls. And 3 balls are drawn at random. What is the probability of all 3 withdrawn balls being red? That's what we need to find out. Okay, so there is a bag, 8 red balls. In question, in exam also, you can draw a diagram like this. This will help you visualize the question. 8 red balls, 5 white balls are there. And 3 balls are withdrawn. So probability of the event, we are withdrawing 3 balls. How many total balls are there? 13. So this is the total number of ways in which we can withdraw 3 balls. We have to select basically any 3 ball out of 13. That is any event. But here, favorable event, we are talking all 3 being red. So how many total red balls are there? We have to withdraw 3 balls, that is for sure. And how many total red balls are there? 8. Now, there are 8 C3 number of ways in which we can select 3 red balls out of 8 red balls. So that's the most favorable case event. What is absolutely happening is we are withdrawing 3 balls from the 13. That is happening. That is the total number of cases. The number of ways or the number of cases favorable to our event E is 8C3 that we are withdrawing red balls, 3 red balls. Is this clear? How have I written P of E? Yes.
Yes, sir.
Okay. So 8C3 means 8 factorial upon 8 minus 3, 5 factorial into 3 factorial. 13C3, 13 factorial, 13 minus 3, 10 factorial into 3 factorial. 3 factorial. 5 cancels 8 factorial by 8 into 7 into 6. 10 cancels 13 factorial by 13 into 12 into 11. 3 factorial cancels 3 factorial. And 6 twos are 12. And nothing else is getting cancelled. 18 sevens are 56. 13 into 11, 143. There's a mistake in our calculation. I guess we have missed something. There's 2 left. There's 2 left. So 2 can cancel 8 by 4. 4 into 7 becomes 28. 4 into 7 becomes 28. And now 13 into 11 becomes same for 143. This is our answer. Final answer. Clear? The trick was only to note one thing, that 3 balls were withdrawn. So the total number of cases this time will be C3 out of 13 total balls. So 13 C3. Favorable event being withdrawing 3 red balls. So now this time considering 8 C3 only. If that is clear, we can move ahead. Shall we? Now the questions level will be slowly increasing. There are lots of questions like bag containing, urn containing 6 white and 4 red balls. 3 balls are also withdrawn this time. What is probability that one ball is red and other two are white. This is what we need to find out. Okay. Now this is our question. Let's read it from the again. So there's a bag. Okay. There's a bag. Six white balls. Six white balls. Four red balls. Four red balls. Three balls are withdrawn. Okay. One, two, three balls are withdrawn at random. What is the probability that one ball is red? One ball is red and two other balls are white. Two other balls are white. That is the probability we are discussing about. Okay. So this time also the probability of event, we are withdrawing three balls. So how many total balls are there? 10. Three balls are getting withdrawn. Now, in our favorable event, there were three balls withdrawn, in which one is of red. So we have to withdraw one red ball. How many total are there? Four. And there is n na? Okay. And other two balls of white color. How many total white? Six. Is this point clear that how we have selected a red ball? So the total number of ways to select a red ball multiplied with the total number of ways of selecting two white balls, and then we have multiplied. This is the fundamental principle of counting, where we are multiplying two dependent events, because withdrawing a ball and other two balls are dependent on each other, because that's the happening of same process, same event of withdrawing three balls. So the withdrawn of two balls and the one red ball, they both are dependent on each other. That's why we have multiplied the total number of cases, P and C. Is that clear? Are there any questions, doubts, misunderstanding, and difficulty in understanding in the question? Is there any?
No.
No. So these are the total number of cases of favorable event, and this is the total number of cases that can be there. Okay, 4C1 is 4 basically. 6C2 is 6 factorial divided by 6 minus 2, 4 factorial into 2 factorial. 10C3 is 10 factorial divided by 7 factorial into 3 factorial. 7 cancels 10 by 10 into 9 into 8. 7 is already cancelled. 4 cancels 6 by 6 into 5. Okay, 3 factorial is 6. So let's write 6 here. 2 cancels 6 by 3. 3 cancels 9 by 3. 4 cancels 8 by 2. 2 cancels 6 by 3. 3 cancels 3 by 3. Is there any left? We have 5 left. 5 cancels 10 by 2. 5 is cancelled. Okay, nothing is left in the numerator. So 1 divided by 2. That is our answer. This question is important. Please reread the question and observe that how we have particularly written this formula. Please prompt when done. Is there any doubt?
No, sir.
So tell me how many prime numbers are there from 1 to 50?
$15, sir.
Yes. Do you remember it or have you Googled it?
Counted it.
Okay. So in a set of natural numbers from 1 to 50, two numbers are chosen. Two numbers are selected. Does the event absolutely happen? You have to find out the probability of both numbers being prime. That is what we need to find out. So if you know it, so let me tell you, from 1 to 30, there are 10 prime numbers. From 1 to 50, there are 15 prime numbers. From 1 to 100, I guess there are 25 prime numbers. I'm not sure. Let me check. How many prime numbers are there between 100 and from 1 to 100, there are 25 prime numbers. That's correct. So we are discussing about 1 to 50 only. So okay. Probability of this event. Total number of cases. We are withdrawing 2 out of 50. And favorable event when we will withdraw 2 primes. So we are withdrawing 2 primes out of 15. Is that clear that how have I written the formula?
Yes, sir.
Okay. So 15C2 means 15 into 15 factorial divided by 13 factorial into 2 factorial into 50 factorial divided by 50 minus 2 becomes 48 factorial into 2 factorial. 48 factorial comes 50 by 15 to 49 and 13 factorial cuts 15 by 15 into 40. 2 factorial cancels 2 factorial. 5 10 ja 50, 5 3 ja 15. 2 7 ja 14, 2 5 ja 10. 7 7 ja 49. Okay, 3 by 35 is our answer. Let me check. No. We are not matching the answer. I guess we have missed on something. 15C2 by 50C2, that's correct. Now let's recalculate the calculations. 15C2, 15 factorial divided by 13 factorial into 2 factorial. 50 factorial divided by 48 factorial into 2 factorial. This cancels this by 15 into 14. 48 factorial cancels 50 by 50 into 49. 2 factorial cancels 2 factorial. Now, yes, 15, 3, 5, 3 is 15, 10, 7, 2 is 14, 7, 7 is 49. And 2 cancels 10 by 5. So it comes 3 by 35. That is correct. Our answer is correct. And the given is 21 by 245. I guess they have not simplified it. 7 3 is 21. 7 3 is 21. Then 35. Then 35. 7 5 is 35. So that's 5 for it. 3 by 35 is the correct answer. Our answer was correct. Okay. Is this clear? Is the calculation, is the solution clear?
Yes, sir.
Great. Let's hold one more question. There's a previous year question now. How many weeks are there in a week, in a year?
52.
52. We have to find out the probability of year having, not year. We have to find out the probability of a normal year having 53 Sundays, 53 holidays in a year. That's a normal year. Now, in a leap year, there are 52, like if we 364 days are there in a normal year. Am I
Sir,
correct?
is it 365 now, sir?
Yes, yes, yes. It is 365. In leap year, this is 366 days. Leap year days. So if we calculate divided by 7, 7 5 is 35, then it becomes 52. 52 weeks and 1 day. 5, 1, 6, 2. 2 is remaining. 2 is remainder. So 2 by 7 week is basically 2 days. So 52 weeks and 2 days. So 52 weeks are there, means definitely there will be 52 Sundays, 52 Mondays, 52 Tuesdays, and this and that, this and that. That is for sure, that 52, everything will be 52 times. And 1 day can be Sunday or Monday or Tuesday. It just becomes that, it just depends on the last day, whatever that was. So 1 day is not defined, but it is very defined that 52 are there for sure. Now, if we have a normal year, so let's exclude this case. No, let's not exclude this case. Let's discuss it later because it's not related to our question right now. We'll discuss it later. So 365 days, 52 weeks. So 52 Sundays for sure. Now this 1 day can be, it can be Sunday, it can be a Monday, it can be a Tuesday, can be a Wednesday, Thursday, Friday, or even Saturday. All it can be any day, right? So the probability of 53rd Sunday, 52 Sunday it is for sure, whether it is a normal year or a leap year, 52 Sundays will be definitely there. What depends on this 1 day? So the probability of 53 Sundays will be 1/7. Clear?
Yes, sir.
So this is our answer, 1/7. Would it have been a leap year? Then would it be a leap year? Then there will be 2 days remaining. So it can be as so 2 days can be like the first day can be Sunday and then the Monday. Then Monday or then Tuesday or Tuesday or Wednesday. Wednesday or Friday, sorry, Thursday. A Thursday with Friday. A Friday with Saturday or a Saturday with Sunday. So how many cases? 7 cases are there. In how many? And now we are discussing about the probability of a leap year having 53 Sundays. So this time, one there's a Sunday. Here is also a Sunday. So there are 2 cases out of 7 in which there are a Sunday. Here is a Sunday and here is a Sunday. So there are 2 cases out of 7. So the probability will be 2/7 this time. Is that clear?
Yes,
Is
sir.
that clear? Yes. So shall we conclude our class? Is there any other question?
No, sir.
Is there any difficulty in your preparation? Anywhere? No? Okay then.